In this lesson, we are going to learn how to identify and resolve common errors in Solidity. We have separated two types of errors for this lesson. We have compile errors and logical errors. Let's start by exploring common compile errors. Compile errors are the easiest ones to debug, since normally the errors appear in the message, and they usually tell us what is wrong and how to fix it. In this case, we are starting by seeing that 1 is not implicitly convertible to the expected type. In this case, we are expecting to return a uint. However, we are specifying 1 as a string. In order to fix this error, we can simply say 1, and that is working now. Okay? Now, let's explore another compile error, in this case, conversion error. In this case, as you can see, we have an int 8 that is called first. However, this function is expecting to return a uint. So, in order to solve this problem, we need to explicitly cast. However, as you notice, it's not working yet. Sometimes we need to do multicasting in order to make it work. Alright, as you can see, now it's compiling. Alright, let's see another type of error. This one is related with the operator. In this example, as you can see, we are returning a uint, but sum is a uint 8. So the first thing that we can do is we can fix this one, but now let's see the error in the compiler. It says that the operator plus is not compatible because first is a int 8 and second is a uint. So we need to convert this one to uint, and we do something similar to what we did in the previous example. Remember that sometimes you need to do casting multiple times, and there it is. Now it works. Okay? Alright. Another common error is the stack depth limit. One of the limitations of Solidity is that we can declare at maximum 16 variables in a function. So, since Solidity only allows us to have a maximum 16 variables in a scope at the time, the way we solve this issue is actually by splitting the code into multiple sections. So what we can do is, for instance, clear a variable called result A, and then we create a block of code where we say that result A is essentially going to be one or first plus second, third, and so on till 8. But if you notice, we are encapsulating in this block of code. Okay? Now we can do something similar here, essentially by splitting in, let's say, result B, and then we simply say result B is going to be equals to, in this case, 9, 10, and so on. Okay, and then finally we simply say return result A plus result B. And in this way, we are splitting result A, result B, and now at the end, we simply sum each one of these values. And that's how we solve this problem. Okay? Alright. Alright, now we are gonna cover another category of errors, in this case, logical errors. These logical errors occur when the code is syntactically correct, but the result in a data state is violating the rules of the language. When this happens, we get what is called like a panic error, because we are doing a illegal operation. Now in Remix, actually it's a bit difficult to debug this because it hides that particular information. However, we are gonna look how to find the error, okay? Now, in this piece of code, if you remember, arrays are index 0, okay? So that means are based on index 0. So that means that the first element is gonna have an index 0, the second 1, 2, and 3. So here we are trying to access, because the length is equals to 4, because we have 4 elements, we are trying to access the index 4, and there is nothing here. So we are gonna get a index out of bounds error, and that's gonna cause a panic. Now let's test it. And here, as you can see, we are simply getting a revert, but we are not getting the details, okay? This is because, as I mentioned, Remix is hiding that. However, we are gonna see more by clicking debug. Now here, let's jump to where the code was reverted, and let's find the memory. What is happening in the memory? In the memory, we are seeing that the first element has this hexadecimal value. Now, Solidity says in the documentation that when there is an error of this type, it's gonna return a panic. This panic error is actually this code. But how do we know it's a panic? Well, if you calculate the hash of panic and this UN value, we are gonna get the following: 4E, 4A, 7B, 71. And when you look at this, can you see they match together? So in that way, you exactly know that it's a panic, but this is just the way Solidity encodes the value. Now, after that, we also have a code. In this case, it's a 32. And if you see, Solidity has a table with a different code. In this case, 0x32 is you are accessing an array and you are getting an out of bounds error, okay? Which is exactly what we are getting because we are accessing an element that doesn't exist, okay? All right, let's go to the next example. This is a gas error, and that can happen if, let's say, we are trying to run an unpredictable function or unpredictable functionality in Solidity. So here I'm simply saying that this thing is gonna run forever, and I'm gonna try to run it. As you can see, also Remix has a way to specify gas. I'm gonna put a lower value and then I'm gonna call it. So here I'm getting essentially the out of gas. Alright, so don't run unpredictable code. Now let's review another flow example. In this case, we have two uints and we are subtracting 2 from the first one that has a value of 1. So that is gonna create an issue because it's gonna result in a negative number, and this value is not intended to be negative. So let's run it. And as you can see, we're getting a revert. Now let's explore the error with the debugger, and remember, we can jump to the error, find memory, and as you can see, we are still getting a panic. However, here we have the value 11, and the 11, as you can see, is an underflow or overflow. Alright, so let's try to solve this issue by perhaps changing the data type and saying, okay, we accept that there could be negative values, so we change the data type, and now as you can see, we get the right values because this data type is expected to also be negative. Alright, now let's see the divide by zero error. Let's run it, and now I'm gonna try to call it. Okay, as you can see, we are getting a revert, and now let's debug. Here, let's go to memory. As you can see, I'm getting also a panic, but now I'm getting an error 12. And if we check the table, a 12 is an error if you divide by 0. Okay? So don't divide by 0. That's the solution.